Alright, picking up where we left off with derivatives and where they are and are not differentiable. The last three examples that you looked at last night are not differentiable. The three places are if you have a cusp, if you have two places where the derivatives are coming in at different angles, and if you have a vertical asymptote, or a vertical tangent line rather. The most common example is the cube root of x, or the swimmer man cube root. The first two can be referred to as pointy places. You cannot have a derivative at a pointy place. In all three of the previous examples, the functions were continuous but failed to be differentiable at certain points. Please note that just because it's continuous, it does not guarantee that if it's differentiable, but it does work the other way around. Differentiability does imply continuity. If I say that a graph has a derivative at a point, then that means that it has to be continuous at that point. Example 4. For the logical statement, if A then B, the converse is written if B then A. The converse of the statement in the box is not true. What is the converse? The converse is if f is continuous at C, then it is differentiable. That is not true. Not necessarily true. It could be true, but we don't know, because a graph that looks like that is perfectly continuous, but right there it is not differentiable. The contrapositive of any statement is logically equivalent to the original statement. For the logical statement, if A then B, the contrapositive is written if not B, then not A. What is the contrapositive? Well, the contrapositive would be if it's not continuous, if F is not continuous, then it is not differentiable. And that is true. You cannot take a derivative if it is not continuous. Example, you could not have a derivative right there. The derivative would not exist. Here is an actual AP question illustrating exactly that. It says the graph of a function f is shown above, and I'm going to be honest, I don't know if this question is in your notes or not. I almost want to say no. If we were here in class, we would be answering this question right now. So take a minute and try to answer it. Pause. Okay, unpause me. The graph of a function f is shown above. At which value of x is f continuous but not differentiable? Well, and you're going to hear me drinking water. I apologize. My voice is about to go out. Which value of x is f continuous but not differentiable? Well, the answer was A. It's not continuous at B because there's a hole. It's not continuous at D because there's a jump discontinuity. It's continuous at E, and that has a perfectly fine derivative. It's not differentiable at A because there's a pointy place. So it was A. Example 6. It says if you were given that f is differentiable at x equals 2, then explain why each statement below is true. Alright, we know it's differentiable. If it's differentiable, we know that it's continuous. If it's continuous, then the limit has to exist. And I should probably write these out. If continuous, the limit must exist. It's like a logical statement. If it's differentiable, then it has to be continuous. If it's continuous, then it has to have a limit. B, that is the definition of the derivative. The limit as h approaches 0 of f of x plus h minus f of x over h, where x is 2. So that's actually the definition of the derivative. F of 2 exists because if it's differentiable, it must be continuous, and if it's continuous, then it exists. This is the alternate definition of the derivative. The limit as x approaches c of f of x minus f of c over x minus c, where c is 2. That's the definition, the alternate definition of the derivative at 2. If f is a function such that the limit, it's actually an old AP question. Which of the following must be true? Well, you need to recognize that that formula is the definition, the alternate definition of the derivative, which says that f prime of negative 3 is 2. So it's saying that it has a derivative, and the derivative at negative 3 is 2, because it's just the f of x minus f of c. Yep. Just ignore the facts that I just got a text message from Travis. Just turn that phone off right there. The limit, so let's make some choices. The limit of f of x as x approaches negative 3 does not exist. Well, no. If it has a derivative, it has to have a limit. If it has a derivative, it's continuous. If it's continuous, it has a limit. So A is not true, because it does exist. F is not, wait, the limit, oh, okay, we're hunting the one that is true. F is not defined at x equals negative 3. Well, no, it is defined because it's continuous, so that's not true. The derivative of f at x equals negative 3 is 2. Well, that's pretty much what it said. So it's C. I don't even have to keep going. Which of the following must be true? Yeah, that must be true. It also has to be continuous. I think D must be true too. Oh no! D, the reason it's wrong is because it says at x equals 2, and the x value we're looking at is negative 3. And f of negative 3 is 2? No, that's not true. F prime of negative 3 is 2. Most graphing calculator, yeah. Skipping, we actually talked about this today. We did that. Use your calculator to find the derivative. I'll go over it one more time just to make sure you're good. I don't want to waste time. New document. No, I don't ever want to save anything. We are adding a calculator. We are in calculus. We want to find the derivative at a point. Negative 3 is my point. And it's x squared minus 3x plus 2. Negative 9. Yay. So we would say f prime of negative 3 is negative 9. Use your calculator to find the derivative of the 3 examples at the beginning. What problems did you find and why? We did that. I actually did that while I was teaching that. So, check. You can also find the derivative. I cannot figure out how to make the TI Inspire do that, but we do not need that function, so we're not doing that. We've already done it. It's f prime. I'm doing the same problem again. That's not necessary. Find the derivative of the absolute value of x squared minus 3x plus 2 at x equals 2. We will go ahead and do that. And you can copy and paste. Don't forget that you can do that. And I wish I could have just selected it and put absolute value, but oh well. X squared minus 3x plus 2. And where am I looking? At 2. So I just changed my value. 2. What in the world? It's plus or minus 1. What in the world does that mean? I just don't know. Plus or minus 1. Well, let's graph it and see. The absolute value of x squared minus 3x plus 2 at 2. Well, it says graph it by hand, but, okay, fine, I will. Alright, what does that look like? What does x squared minus 3x plus 2 look like? Well, if I factor it, it has intercepts at 2 and 1. And it's a parabola, so it's going to do this. What does absolute value do to the graph? Do you remember? I'm letting you think. You don't remember, do you? What it does is it comes down and it flips the part that's below the x-axis above. So the purple graph is actually the graph of the derivative. The graph of f of x, not f prime of x, is the graph of the absolute value graph. Now, at 2, does the derivative exist? No. because there's a pointy place. So your calculator just lied to you. So make a note, anytime your calculator gives you multiple answers for the derivative, that means the derivative does not exist. You got to be careful. Your calculator sometimes lies. Find the derivative of 1 over x at x equals 0. Oops, using my calculator. Menu, really? Probability? No. Derivative of point. Where did it say 0? Like y'all are going to talk to me. You're not even there. 1 over x. Negative infinity? What does that mean? That means it doesn't exist. Make a note. If your calculator tells you negative infinity, it does not exist. The derivative, using any of the three definitions of the derivative, let's use the first one. H approaches 0 of f of x plus h, so 1 over x plus h minus 1 over x over h. We have to get a common denominator on the top, and I have this feeling this video is getting long, so I'm fixing to cut it short. X plus h, x, so that's x, and that's x plus h over h, so that's x minus h, x plus h, h, cancel, 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 so we get negative 1 over x plus h times h. We're going to pull our limit back in, going to 0. What does that mean? It means it does not exist. Why doesn't it exist? Because the graph doesn't exist at 0. So if the graph is not continuous, if the original graph does not exist, then there's no way the derivative can exist. You can't find the slope of something that's not there. And, okay, last one. Using your calculator, find the equation of the tangent line to this graph when x equals 2. Equation of a tangent line, equation of the line, okay, x is 2. I'm going to go ahead and find y. 2 cubed plus 2 squared, that's 8 plus 4 is 12. All I need here is my slope. Well, the slope of the tangent line is nothing more than the derivative at a point. So x cubed plus x squared, where x is 2. Menu calculus, x is 2. What did I say? X cubed plus x squared, 16. And so my slope is 16, and I am done. Wow. How about writing that in a real thing? All right, when you finish that, go ahead and do worksheet 3.2, and we are doing all of them. You will find the answers on Edmodo.